Okay, year 7, we're looking at suggested improvements and extensions. So that's like almost the last bit here. So looking at how our experiment can be improved or extended, and that way you can show that you've actually considered the scientific process and the reliability or the validity. So how your data actually does answer the question. Okay, so we're proposing suggested improvements and extensions and identifying improvements and extensions. So that's what we need to be able to do. Okay, let's have a look over here. So I've got my OneNote open up. It's just got everything here. So let's break it down. I've got the scaffold titles and the little bits of writing underneath each one, those there for you, and they've come from your sheet here, so it's the same place. I know that you can't really see that video, but this sheet there, and they're on here, so that's the reason why I've got my checklist that has that information there and my actual data there, so I can identify anything that might be amiss. So what we're going to do first of all is we're looking for sources of error. So where could there have been a mistake or something that hasn't gone well, so in the experimental process, which could impact like how your data was collected. Now I'll let you know right now, I saw students using meter rulers, and there is an inherent, so there's an inaccuracy in that, because every time you have to pick up the ruler, you have to put it back down. And if you're doing that enough times, sometimes they can be just a little out and you might not have the right marker point, and then you might have errors in your distance measurement. You might find that you might have let go of the car and it's hit, as it goes down the toy ramp, it might have hit like a lip in the concrete, which impacts your results. You might have blown up the balloon and the balloon stretched, but then you reuse the balloon. That might impact your results. So that's what we mean by brainstorm a list of experimental errors that occurred in your investigation. Like what could happen that could impact it being like a really fair test, or making it could change your data. So that's what we're looking for. Like, and I have a look here, like sources of error. Like I see this here in this data set that we've got. Why was it another almost over 20 centimeters longer? Did something happen in that low trial that was different to all the others? These ones are pretty close, but then it's saying again, something happened here. So there must have been something that's happening that we don't know. So it might have been like a mistake in measurement. You did your experiment, so you have to identify something. So it might be in the experiment, it was noted that could affect the accuracy of the results. Sorry, we should start off with the topic sentence. Results. These were, whatever they were, and then it will be such errors could result in changes in the experimental results. Okay, there you go. So I'm just going to change that so it's a bit easier for you guys to read. There we go. And I'll just put that in a different, oh, that's not going to be good. Actually, just leave it as no color. All right. So whatever those results were, so you might have dot points. So error 1, error 2, error 3. You can understand why I haven't given them, because it's very specific to your experiment. So I've given you some suggestions of where it might have been. You might need to refer to your teacher if you're unsure, or your other the group that you worked with, to find things that you think that might have been or could have been done better. So those experimental results. Now, how could these be removed? So if you've got 3 different little errors here, you could be like, these, oh wow, that's horrendous. 14. These errors could be removed if the following improvements were made. So you might have an improvement, so you might be like improvement 1, improvement 2, and improvement 3. Now I guess if you had 3 errors, you would have like an improvement for each one. You might find that doing one improvement actually removes multiple errors anyway. So whatever the case is though, basic suggestions for improvements and extensions that relate to the main findings. So that's all good. But what we want to be able to do as well is explain why. So improvement 1, whatever it is, this is because. Now, should have a capital letter there. So something would be using the error in measurements. This could be improved by having like a marker point where you start all measurements and measure from there. And that could reduce, that marker point could reduce variations so that it's the same spot being used as the starting point each measurement. So that's a way of reducing error as a result of people not using the equipment accurately. Okay, so using that, this is because it just demonstrates that you are thinking about things at a higher level. Okay, and then suggested extensions. So that would be what variables could be changed in an experiment. So it has to be relevant, so logically derived. So remember your experiment was to look at something relating to friction and forces. So you took an experiment, let's go with the toy ramp because I've used that now for the analysis. The toy ramp, we changed the angle, and then your experiment, you may have changed the surface of the ramp. So you've changed the surface of the ramp, so the next progression might be changing the mass of the object, or changing the different objects rolling down the surface. So you might have different objects and their distance traveled. That's logically derived, okay? Because what we're looking at now is like, well, if there's different types of surfaces on the object moving down the ramp, that relates to friction. Okay, so that's what we're looking for in regards to that. So what variables could be changed and extend the experiment, investigate another research question. So what you should be doing is italic state and no color. State the new variables being tested. How. Let's start you off with a topic sentence, hey? Experiment could be extended considering variables. And then you would state what those variables are, and then how that relates to your experiment. Not the original one, hold your experiment. Okay, so that's what we're looking for. I'm not going to write that there for you because I'm giving you a sentence starter, and then you need to fill it in. So you would have a sentence about this, and then how that relates to your experiment being completed. So again, looking at that checklist, skillful judgment is evident in suggesting improvements. So that just means like, are you thinking about how it logically comes from your research question and how you are going to extend it? and it's linked to your data. So you may have found that, yes, you've got different distances being traveled with depending on the surface. So the rougher the surface, the less the distance travels. So now you might look at the surface type of the object being rolled down the hill, because that would be a logical progression of modifying the experiment for extension. Okay, so if we have a look here at our ISMG, I'm just going to make that a wee bit bigger. And hopefully I can, there we go. Okay, so we are looking at this section point here, draw. So this dot point here. Evaluation, so that's to find the value of something. So you're weighing up its pros and cons, and then making a decision based on that. That's what it means to find the value, or pros and cons, and to find, evaluate means to find the pros and cons to determine the value of something. So is it worth going on, or that's what we're looking at here. So what we're looking for is they're always the evaluation, but how that evaluation varies is obviously these bold words, critical, which means that you are thinking about it in all aspects at a objective manner, thinking like how it could be improved. Basic, you've had a look at it and gone, yeah, this is something that needs to be improved, could be better. And superficial means like you've just kind of gone, yeah, that's not good, and that's really good, and then that's about it. Okay, so there we go. There's those bolds. Logically derived. So I gave you an example of that. It's just like related. So you might be like, well, I did toy ramps, so maybe I can change the size of the car, like the car wheels. Like it is related to the experiment, but it hasn't been logically derived from the results you got from the surface. Okay, and then suggested improvements. Yep, there we go. So it's logically derived. So again, improvements. So if you have an improvement, and this is because, like, how does it link to this? That's what we're looking for with this logically derived, is like, well, you've made this improvement, it's because of whatever error it was. You've made this modification, but how does it relate to your data that you found originally? Okay, so that's what we are looking for in interpreting just that dot point there, the second part of your interpretation and evaluation. Okay, don't forget to pause, stop, rewind, rewatch, so that you can analyze, so do what we're doing, identify improvements and extension for your investigation. There you go. Okay, thanks everyone, bye.